Okay, here's another question that caught people out a bit, talking about devising and using your own opcodes. So you're told that the assembly language program is written for an instruction set that uses 4 bits for an opcode. That's the only thing we need to worry about now. And then it asks you to devise binary codes or opcodes for the operations load, add and store shown in this assembly language program. The word devise there means that you can create these yourself. Now remember, we're not expecting you to know the details of any particular processor's instruction set. Devise binary codes, so create them yourself for the operations load, add and store. So, well, you kind of think, well, fair enough, load, add and store, they're each going to need a 4-bit code, and you can make those up as you go along. So, just find my pen here. Load might be 0, 0, 0, 0. Add 0, 0, 0, 1. And the store, you might have 0, 0, 1, 0. And quite a few of you did manage to get something along those lines. As long as you had a unique 4-bit opcode for each of those functions, you would have got 3 marks. However, it's worth bearing in mind, if we look at the question here, that the question is actually worth 5 marks. And it also says under here, your code should take account of the addressing modes employed. Now that's quite significant, isn't it? And that's why I've labelled up here with the 2 different meanings of load, and they also apply to add as well. So you can see here some of the numbers have got hash signs in front of them where it says load hash 100. That means instead of loading the value from memory address 100, we're actually going to load the value 100 itself. So there's 2 different options for loading, aren't there? We might be loading a number, or we might be saying, okay, load from this address. So that's what's known as having different addressing modes. Either the value will be in the operand itself, or it will be stored in memory, and we need a way of distinguishing between those 2. So it's not enough just to have the 3 values that we've got below. So what you'd need to then do is add on 2 more, because you'd need to specify that this is a load, oh, I lost my pen, from memory. This is an add from memory. And then obviously store. Storing is always saying store it in this memory address. You can't store just the inner value. That wouldn't make sense. It's always saying store in this memory address. So we only need 1 for store. Hence the 5-mark question, because 2 for load, 2 for add, and just 1 for store. Okay. So what we would need to add on here, and I've not left myself a great deal of room, let's have a look and see what I can do about that. Oh, hello. Okay, just sorted that out to give myself a bit more space. So we've established, haven't we, that we need 5 different opcodes here. So we're going to try having a load. I'll just zoom in to give myself a bit more control over this, I think. Maybe I won't. Okay. So that could be a load from memory. And then we might have 0, 0, 0, 1, which would indicate a load from operand. 0, 0, 1, 0 could be an add from memory. And 0, 0, 1, 1 could be an add from operand. Excuse my writing, it's very difficult to write with my finger on this. And then finally we could have 0, 1, 0, 0 being the store operation. So that's all you needed, is 5 different unique opcodes. It doesn't matter which opcode you've assigned to which. As we said, you were told to devise your own. The next part of the question that you need to look at is where it says using your opcode, translate this fragment into its equivalent machine code. So all you need to do now is make sure that you use your opcodes correctly. Whatever they are is fine, but you need to make sure that you use those correctly to translate this into its equivalent machine code. So if we just move on to, here we go. So we're wanting to load the number 100 first. That's the first thing that we've got to do. And we've got our 4 bits for our opcode and then the 8 bits to represent the operand. So in this case we're wanting to load the operand. Load the operand is 0001. So we're going to say 0, oh that's not a pen, 0001 being our load from the operand, and then the value 100, which you can work out using your binary code knowledge that you already have. So that says to load the number 100. The next thing we need to do is store in 254. So I know that our code for store was 0100, and that the value for 254 is this. So hopefully you can begin to see the pattern of what is going on here. You're just working out the first 4 bits based on the code you did in the first part of the question, and then the operand based on just converting the number into binary. We'll do one more. I'm not going to do all of them for you, but we'll do one more and then maybe you can finish the rest of them off yourself. So the next thing we need to do is add the number 25. So if we have a look back at what our add was, the operand is 0011, so 0011 for adding the operand, and then the value 25. Okay, so that's how to answer that question.